Okay, we're at section 18.3, resistors in parallel. So let's start the um, PowerPoint. And they show a artist rendering of a battery and two resistors. Last time it was just a single loop connecting one wire, that wire connected to the next one, that one connected back to the battery. Here, this is what is called parallel. You can see coming out of the positive, it goes to R2 and R1 on one side and comes out of R1 and is touching R2 and back to the battery. This is a parallel configuration. So if in the previous one, if R1 would have blown open, if it would have caused an open circuit, you wouldn't have any current flow at all. It requires that all of the uh, light bulbs work. One of them breaks, the whole thing stops working. Here, if R1 were to blow, to be an open circuit, R2 would still be working. And that's how the household your household lighting works. I mean, it's all done in parallel. Not the whole house. The whole house is done, and it's you have branches. You'll have like the kitchen lights and the living room lights and the bedroom lights. They're all on one parallel circuit, and they're in series with a circuit breaker, such that the circuit breaker trips if it goes over 15 amps or 20 amps. Um, but anyway, this is a series. I'm sorry, a parallel circuit, and if you were to take a voltmeter and measure across the positive anywhere on this red and put the negative probe of the voltmeter anywhere along this black, it would all be the same voltage. So the voltage across components in a parallel circuit is the same. The voltage is the same. However, the current is different in each branch. So there's a branch that goes from the plus through R2 back to the minus. There's a branch that goes from the plus through R1 back to the minus. And those currents could be different depending on the value of the light bulbs and the resistance in each. So in a series circuit, you have one current, but you could have multiple voltage drops. In a parallel circuit, you have one voltage going across all the components, but multiple currents. So here it says resistors in parallel. The potential differences across the resistors are the same. Let's make sure. Yeah, okay. A circuit. Here's the circuit diagram for those two resistors and the battery. So you can see that V1 equals V2 equals delta V, what the battery voltage. However, you see that you have a current coming out of the battery, and it splits into I1 and I2. And those eventually, and that's at A, that split takes place at A. At B, they join back together, so you get the same current, the same value of current as that leaving. And so the circuit diagram with the equivalent resistance of the two parallel resistors is 1 over R equivalent is equal to 1 over R1 plus 1 over R2. So you have I1 equals I1 plus I2. I1 equals delta V over 1 over R. I'm sorry. Delta V equals I1 equals delta V over R. I2 equals delta V over R2. So I is equal to delta V over the R equivalent. And you can see that you have delta V over R equivalent, that's equal to, just as I equals I1 plus I2, delta V over R equivalent equals delta V over R1 plus delta V over R2. So it's the reciprocals. 1 over R equivalent equals 1 over R1 plus 1 over R2. And if you have multiples, You just keep adding them, but you have to be careful because a lot of students will take that 1 over R equivalent and assume, oh, I'm done. You have to take the reciprocal to get the actual value. Now let's go back to our iPad, and if we have a circuit here, and we'll look at this whole length. We're assuming that these are the same. You'll see that the length is the same for each of these. Now, if we were to look at cross-sectional areas of this one, we have an A, and at this one we have an area. So what have we done? We've just increased the area, which current comes in here, and it instead of going through one, where an area is like this, now it's going through two, so the area has increased. So we have to add these areas. Well, how do you add the areas? You add them as reciprocals. So that's you can remember that when you have when you're trying to remember which one is which. I did the same thing with the capacitors. Now let's look at you have 1 over R equivalent equals 1 over R1 plus 1 over R2. Now let's get a common denominator. So we have R2 over R1, R2 plus R1 over R1, R2. So that's equal to R1 plus R2 over R1, R2. And when we take the reciprocal of that, R equivalent, we get R1, R2, the product over their sum, R1 plus R2. Now, this only works when you have two. If you have three, you have to go through and you have to do the 1 over R equivalent equals 1 over R1 plus 1 over R2 plus 1 over R3 plus however many you have. You have to do this. But always remember to take the reciprocal to get your R equivalent. Okay, that trips up some students, and they probably even make the test banks where they have the reciprocal value. So they say, oh, there it is. I'll circle A because that's the value. No, you have to take the reciprocal of it before you can get the final answer. Okay, let's go back to our PowerPoint. If this doesn't help you, doesn't help you remember, then just forget it. Just memorize the formula. I think it might help students. Let's go back to the PowerPoint. All right. And I think actually this slide is just, they're talking about household currents and how, or household wiring and how the lights are wired in parallel and not in series. If they were wired in series and you one were to blow, then the whole thing would blow. And even lamps. I mean, I've got a lamp up here. 2 of them are out, but 3 of them are still lit. What does that mean? That means they're in parallel. Because if one went out and they were in series, they'd all be out. And I think that, oh, well, they have problem solving. And this, you have to be careful with this one. This is their problem solving strategy. Simplify circuits with resistors. Combine all resistors in series. R equivalent equals R1 plus R2 plus R3. The current in each resistor is the same. That is true. Combine all resistors in parallel. R equivalent, 1 over R equivalent is equal to 1 over R1 plus 1 over R2 plus 1 over R3. If you have just 2 of them, you can use the little shortcut that I showed you. The potential difference across each resistor is the same. repeat and use Ohm's law. In other words, repeat until you get it down to one equivalent resistor. Now, the trick is sometimes recognizing, and I saw this with some of you when you'd come up and ask me questions, recognizing when components are in series and when components are in parallel. So if there's any anything between a node, that you may not have resistors in series. You may have to you have to be careful how you combine them. You can't just say, oh, well, all of these are in series, combine those. It was the way they show the steps here, 1 and 2. Sometimes you have to solve the parallel first and then get the series. It depends on how they're arranged. So this simplistic formula doesn't always work. So just be careful. And that's the end. Next is Kirchhoff's rule. So we'll stop it here.